Hi, Susie. The YouTube should be live. If you can check our channel to see
Yep,
if it works.
I'm trying to go for it just now. Yep, works for me here. Yes, I think it works for me here.
Okay, what do you see? Let me try myself as well.
I just see the cover.
Okay.
Turn. Can I? Yeah.
Okay, so it should work. Yeah.
I hurt myself. Okay, nice.
Let's check. Let me put your guys' face on to see if it works. View. Okay, now it's speaker mode.
Okay. Yeah, I can see you.
Okay, good.
Okay.
Susie, maybe you can send a reminder to all the speakers. So we're starting now.
I didn't hear you. What did you say?
Please send a reminder email to all the speakers. We are starting now.
Okay. Okay.
Hi.
Hi, Tiff.
Hi, Bruce.
Hi.
Hi, Yilun.
Oh, hello. Wow, they're pretty early.
We have about 3 minutes before we start.
Sure.
I'll start to present the share screen.
Sure.
Okay, in 1 minute, we'll start. And Susie, please check if the YouTube is still doing okay, the live.
Yep, it's doing okay for me.
Okay. Okay, it's 9 o'clock sharp. Let's get started. So, hi everyone. This is Bruce, co-founder of NKN. Today, we're going to have the Web 3.0 Tech Talk 2021 edition, Apps and Developers. So actually, we started this Tech Talk series last year in 2020, in the kind of the deep winter of the crypto winter. At that time, we also had 6 projects, all working in the Web 3.0, and we shared our ideas and how we can use the Web 3.0 infrastructure to build real applications. So we're very glad that this year we can do it again, and we have a really exciting panel today, and each of you will going a little bit deeper into their individual products and projects, and then we'll have, in the end, some Q&A session. So let me share my screen. So as you said, as you can see from the screen, so we have Neeraj from Bluzelle, We have Raullen from IoTeX, Dietrich from IPFS and Protocol Labs, and we have Yilun from NKN, Kevin from Storj, and TF from Taxa. So we have the tech leads, and we have the CTOs, and also have ecosystem.
Bruce, we can't see the screen share.
I'm actually sharing. Maybe there's some latency. Can you try?
It's on YouTube Live, it's fine, but on Zoom, it's not working.
Can you see the screen now?
No.
No. And
Okay, let me
YouTube
try
also
again.
disappeared.
Oh,
Okay. Okay, let me do it a little bit differently.
There is an option to put the deck to your background. Maybe you can try that.
The deck to the background. Let me
oh,
see.
there we go.
Yeah, we can see it now.
Now we can see it.
Okay. Okay, good. So I just had a little bit of introduction. So we have the CTOs and tech leads and ecosystem leads. So it's a really good kind of speaker lineup. So I'm very excited to hear because many of them I have met in person, but I don't know what they have been secretly working on in the last year. So it will be very exciting to hear from them. So before we start the full speaker list, I want to kind of say something about why we choose this topic and why we decide to work in this space. So one of the kind of the thesis we kind of really build upon is a seminal article by Chris Dixon, who is from the Andreessen Horowitz, one of the most famous kind of VCs in this space. So he wrote an article called "Why Decentralization Matters," right? So people are thinking, okay, yeah, you have this freedom and the security and other things, but at the end of the day, those are really important, but that cannot be the only thing that Web 3.0 should be, right? So, and he pointed out very clearly why Web 2.0 did not work, right? So this is a very famous chart. So let me explain what kind of relationship between the platform and the users. So in the very beginning of the platform, let's say Facebook, right? So they need to attract users. They are super nice to the users because they want to onboard users, attract users, because users contribute lots of content. But over time, when it's reached a certain point, actually, there's no more new users to acquire, then the user become their product, right? So it's well known that you'll be monetized and all your content you contributed in the end actually make ways for them to make money off you even more, but you did not get any compensation. And some of the other thing is really the platform also, instead of collaborate with the developers, creators, and business, they actually compete with them. So one very kind of obvious example is this, I think it was the Zynga. This application was game development on top of Facebook. So once Facebook grow to a certain size, in the beginning, they really like Zynga because Zynga bringing new users. But after a while, they basically just alienated Zynga because they started to develop their own applications and games on top of that. So you can tell that Web 2.0, centralized platforms like the big internet companies of today, they inherently, they make money off the users, and whoever who contributed in the very early beginnings, like the users, developers, and partners, they eventually become the ways for them to make more money instead of their partners and co-owners. So I think Web 3.0 can fundamentally change that because early users and early contributors, content owners, and developers will become part of or kind of co-owner of the network. So they grow together with the platform instead of kind of become competitors in the end. So that's the reason I think when we look beyond the kind of DeFi and NFT and all the kind of the crypto stuff, and you will say, well, crypto is growing tremendously, for example, from 200 billion total market cap from when we had the first summit to today, it's about 2 trillion, right? So there are 10 times change. But still, in the real world, it's a still small portion. It's probably about the size of Apple, if I remember correctly. So for the projects in this space, like we're talking about today, our ambition is not become the biggest fish in the crypto pond. Our ambition is really, how can we compete with Web 2.0 giants, the Facebooks, the Googles, the YouTubes, the Microsofts, and how can we actually become the future of the internet? And then I think you can understand what's the potential for all the projects presented today. And then the last one, very quickly, I did a very kind of off the back of my hand kind of survey. So how can we use Web 3.0 applications in the normal use, right? So let's don't talk about NFT or DeFi for a moment. So if you look at the popular apps that people use every day, you have the entertainment side, you have the social networking, and you have communication or chat and messaging. And if you look at the Web 3.0, there are a few pioneers, but we are very, very early. So like what Dove one, who is a famous VC in this space, said, we're in the first 3 minutes of the Web 3.0, the first 3 minutes of the crypto revolution. So if you compare how many users all these applications have and how many users the Web 2.0 companies have, and you know all our Web 3.0 projects still have so far away to go. And I think we all will have a tremendous opportunity to have those if we can actually utilize these decentralization and the ownership of the community and the economic incentive to really build true competitors to Web 2.0 and not only an alternative to Web 2.0, but maybe better than them and eventually overtake them. So that's the future we're looking at. And that's the future. All the projects today will tell you how they are built upon this thesis and how to build toward that goal. So with that, I'll close my introduction and I'll start our first speaker. So let me stop my... our first speaker is from Bluzelle. So he's the CTO of Bluzelle, Neeraj, and he does have lots of crazy stuff in the database space. And so I think maybe he can give himself a short intro, and then let's go on to his presentation. I'll share his presentation on his behalf. And Neeraj, please feel to mute your microphone and please start your presentation. Let me switch to your presentation.
Okay, thank you, Bruce. Yeah, thanks for that intro. I actually hadn't prepared a personal intro, but I'll wing it. So yes, I'm the CTO of Bluzelle. Real quick, Bluzelle was started in 2016 here in Vancouver, Canada. My co-founder is based in Singapore. I'm here in Vancouver, and we have built a Web 3.0 database. So that's going to be the subject of my conversation today. And yeah, we can move on to the next slide, please. So real quick, before I get into the actual structure of my conversation, I'm going to talk about our Bluzelle network. Our Bluzelle network really is founded on BluzelleNet, which is our blockchain. We are powered by Tendermint Cosmos, and it's a delegated proof of stake network. And that's what enables our Bluzelle database. Our validator nodes are a critical part of our infrastructure. They provide the storage, and more critically, they actually participate in consensus to determine which transactions are approved and which ones are not. And they're obviously incentivized through the proof of stake system that we have. Our database sits on top of that. And then we have our ERC20 token that we did an ICO for in 2017. So we have a one-to-one parity between our ERC20 token and our native token that runs on our blockchain directly. And then we have a staking dashboard, which is really one of the only consumer products we have. It's a mobile and web app that token holders can interact with, and it allows them to stake their tokens, delegate them, see their yields, et cetera. So we have a lot of consumer incentives to participate. High level, what is Bluzelle? We're the Airbnb for data storage. So just like how people can rent out excess real estate space for renters, we enable validators, nodes to rent out the excess disk storage they have to power our database. Next slide, please. All right. So I'm going to go through 5 questions that I've selected that I believe are pretty critical to understanding Web 2.0 versus 3.0, especially in the context of the database. So the first question is Web 2.0 databases versus Web 3.0 databases. Why is Bluzelle better? And implicitly, I'm going to answer a few questions about 2.0 versus 3.0. So we are a decentralized database. And, that's a pretty loaded term. What does that even mean? Why does it matter? A lot of people don't know that. And we're going to get into some of the obstacles, but let's get into why is it better? So I'll start by saying that, we're managed by community stewards. And what does that mean? Well, traditionally, if you use a database on Amazon, it's managed by AWS. They get to decide who's in, who's out. They can censor things, all that stuff. They control everything. We don't control it. The stewards in the community do. What does that entail? What does that mean? Well, that means the database is always available. It can't be shut down. Bluzelle, my company, myself, I can't shut anything down. It's up all the time. It's a trustless consensus algorithm. What does that even mean? Well, trustless, ironically, actually means that you can trust the network a lot more than you can trust the traditional network. We'll get into that a bit later, but it is a bit of a psychological leap, and that's one of the obstacles to getting into Web 3.0. The data can't be tampered with. It goes back to availability. Nobody can go in and change your data, whether you're making popular ideas or unpopular ideas. The data you store belongs to you. You have provenance. So it's censorship resistant. And that's something new. It's something that developers have never really had access to. And of course, that leads into data integrity. It means that the data you're storing on a Web 3.0 database like Bluzelle is going to be safe from any sorts of tampering, and your integrity is maintained. All right, we'll move on to the next slide, please. So what are the obstacles to adopting Web 3.0? Well, it's a psychological leap. Developers, they need to educate themselves more than ever before. There's so many things they need to understand. One of the big things that I won't get into much detail here is trustlessness. When developers who are not accustomed to Web 3.0 hear about that, they don't understand it, and they wonder if that's worse than centralized. It's actually better when you don't have a singular authority like a data center company running your infrastructure, and you've got a community of providers like the validators on our network. You actually can trust them more because you don't have the collusion. You don't have any real way for yourself to be shut down. And one of the examples here is adopting new patterns, like IP addresses are going to keep changing. If you're a developer and, for example, you connect to DynamoDB or Cosmos DB on Microsoft Azure, you're used to the fact that your entry points are the same. They don't change. The IP addresses don't change necessarily. Now, with a Web 3.0 infrastructure, IP addresses are going to typically change. Servers will come up and down, and that's actually part of the design, that things come and go, but overall the network always persists. Now, there will be workarounds where you could have dynamic IPs and things, but that's the basic idea. One of the biggest things that people don't understand about decentralization is typically it is slower than decentralized networks are slower than centralized one. There are trade-offs. Hopefully that will speed up, but that is how it is right now. This is just the cost of having a network that has to go through the consensus algorithm and provide all the benefits that we've discussed. Next slide, please. So how does Bluzelle nurture and grow our own development community, and how can you as a developer benefit from this? So we actually regularly have bounty programs that are running. They're usually running all the time, and they're basically a call to action to the public to participate in certain requests that we have. It could be project requirements to build an app, maybe a WhatsApp, a chat program. They're typically consumer applications. They could be backend, and we provide crypto rewards to the winning projects. And sometimes we have multiple winners. We have an active Discord that I want to talk about for a moment. We cater to pretty much any developer community subgroup out there. And, one of the things that I, as a developer, always want to have is a very active but healthy and friendly developer community. And we really strive to do that. So we welcome any developer who's interested in using our technology to come in and talk to us. If there's no such thing as a dumb question, you're always welcome to come in there and contribute. We set aside crypto funds for project grants, so you can apply for a grant, and if it's approved, we will give you crypto funds, Bluzelle tokens, to fund your project. And we have programs that come and go, like Swarm of Duty, which is listed on our slide there. And Swarm of Duty was a program where we incentivized more so than developers, operations people to run nodes and achieve uptime. And this really increases or hardens the strength of our network. So these are another way that we really strengthen the infrastructure of our network. Next slide, please. So what are my general thoughts? This is actually an important slide to me. Well, I'm actually a politician as well as an engineer. I'm a libertarian in Canada. I've run in several elections here, unsuccessfully, unfortunately. So what is Web 3.0? To me, it's about liberty and responsibility. We're shifting all of this into the hands of you as the developer and ultimately indirectly to the consumer. This is actually really important. With Web 2.0, you don't have that liberty. You don't have the freedom to do what you want. If you break certain rules, whether they're geopolitical or they violate the rules of your ISP, you could be kicked out. You could be blocked. You also aren't entirely responsible. If you get blocked or your password get resets or whatever, you can get in. Now, with Web 3.0, you are given a lot of power with all that liberty. Your data is not going anywhere, but you also have the responsibility to own all your keys. If you lose your information, if you lose your keys, there's no one to call. You're locked out. That is a pretty major responsibility to take on. One of the big things about Web 3.0 that hopefully some other parties will talk about is that computers are now going to appear to be intelligent beings. With Web 1.0 and 2.0, they weren't. They really were just glorified calculators. They executed algorithms and really they didn't do a whole lot more. With 3.0, especially with blockchain, we're going to see that computers are going to appear like living creatures. They're going to react to data dynamically and be able to do heuristics and things that are, AI. These platforms are going to be truly censorship resistant. And I wish I had more time to talk about that, but it really means that they're going to empower the marginalized groups. It's so critical in society for unpopular ideas to be able to foster themselves. Sometimes unpopular ideas actually change the world. We've had unpopular ideas over the last 1,000 years that eventually became accepted. Look at Galileo, look at the people that were against slavery in the United States. All these ideas at one point were considered dangerous and almost criminal. We can't block free speech. And Web 3.0 is going to make it easy to ensure that unpopular speech, not necessarily hate speech, but unpopular speech will propagate, which is critical for the evolution of our Western civilization. Next slide, please. So here's a kind of a tongue-in-cheek question. When will the Web 3.0 app actually displace incumbent Web 2.0 apps? So for example, you got your YouTube, you got Twitter, you got WhatsApp, et cetera, et cetera. When are we going to have Facebook displaced by a replacement for it? Well, I don't have great news for that. I think it's going to take several things. There's going to be a consumer shift required in mindset. Consumers fundamentally don't care about a lot of the stuff that I've mentioned yet. They're really more interested in, tweeting about whatever it is or, commenting on things. They don't understand or appreciate some of the things we're talking about. I think developers do, but consumers are going to take longer. They're the last people to adopt Web 3.0 benefits. So consumers are okay with the shortcomings, and that basically means the pain points for Web 2.0 just don't exist in the consumer space. It's going to take time. When those consumers have gotten frustrated enough, and they will, they're already starting to notice it. When they start to get frustrated enough with the antics of Web 2.0, they're going to automatically start looking for the alternatives to that. One of the, I guess, smaller examples of that is cryptocurrency, which, I didn't spend a lot of time talking about, but cryptocurrency is a big part of Web 3.0. Because of the quantitative easing and, just the fundamental printing of money that's been going on in the Western world due to COVID, you've already seen inflation is starting to take place. You're starting to see that normal average people, not computer geeks, are worried about their net worth. They're worried about where their money is going and what is their Big Mac index. What's their ability to buy a Big Mac tomorrow? And they're looking for alternatives. And cryptocurrency has skyrocketed since the start of this whole COVID. So that's already an example that consumers, they're slow, but they are going to get frustrated and they are going to start adopting this. And one of the reasons I think that this event is critical is we need to get developers on right now, because the steps are we get the developers on, they get excited, they start moving into Web 3.0 and they build those apps. And the developers that get into this early, those are the ones that are really going to win in the Web 3.0 space. They're the ones that are going to have those apps that those consumers are looking for. So yes, that was a bit of a lightning speech, but I think my 10 minutes is up. Is that right, Bruce?
Yes. Yeah.
Okay.
So thank you, Neeraj. And I think I saw some questions in the Q&A and also on YouTube Live. So we'll do all the Q&A toward the end so we can actually get moving on. So thank you, Neeraj, for the lowdowns on the Bluzelle and also your interesting thoughts about politics and humanity. So I think that's interesting.
Thank you.
So let's move on to the next speaker, Raullen from IoTeX. So let me switch to the next slide. So Raullen is CTO of IoTeX, and he had lots of experience in cryptography and also working large Web 2.0 companies in the past. So let's hear him talk about IoTeX and how he's going to use decentralized infrastructure for an open machine economy. Let me put you on full screen.
Thanks, Bruce. Thanks, everyone, for having me. Yeah, it's my honor to be here to talk about IoTeX, to talk about our vision for the decentralized infra for machines, the Web3 for machines, right? Yeah, so so the presentation is called Decentralized Infra for an Open Machine Economy. Next slide, please. Do I have control? No, right? Yeah, so basically IoTeX started back in 2017. I think among the same time with all the probably other projects here. So we envision to be the decentralized infra to power machine at scale. So what does that mean? So basically we are equipping the machines with full stack trustworthiness, blockchain trusted hardware, some authentication protocols. And also we're incentivizing them with dynamic token economics. Everybody knows the token economic is the silver bullet for different type of crypto projects. So we definitely want to bring this one to the machine world. And third one is we want to extract the value of machines for the entire crypto world. So as everybody can see, like the machines that surrounding us are actually become more and more. So there will be 40 billion machines by 2025. So there will be like a tremendous what we call MEV, machine extractable value, to be out there. For example, a very good example is like Oracle. So you can think about machine as a way to interpret the real world in a verifiable way, right? So which actually collects information and through back to the blockchain. So that's kind of like an Oracle view of how a machine MEV works. And another way is to think reversely is once the machine becomes smart enough, intelligent enough. So basically we can use some fractional ownership, decentralize some automation here to let the machine serve the human being better, So that's another way. And the third example is basically like a botnet. Everybody knows botnet, but definitely like we can have botnet in a very good ways. So that's kind of like a three very typical examples about MEV. Next slide, please. Yeah, so IoTeX is kind of like an umbrella project for lots of things that is ongoing. So underlying, we have IoTeX public blockchain that has been built like 3 years ago from scratch. So that's the foundation for the trust, And then built on top of the blockchain, we have different middlewares. We have smart contract, of course, it's EVM compatible. We have sovereign machine protocols, which I will talk about in the next slide. We have cross-chain protocols. And also, most importantly, we have open hardware spec to allow different machines to onboard here to do different things. And on top of that, of course, we have Wallet, SDK for developers, Explorer for users, Device Portal for machines, and the Governance Portal for token holders and the participants into the entire ecosystem. And most interestingly is when we look at the application level of IoTeX, definitely like there are two groups of applications. So one is like a very typical Web3D app. For example, Mimo is our DEX, Cyclone is a privacy preserving protocol, Travel Cat is an NFT game, Mint Token is another token minter, Vita is like community token. It's very similar to Ethereum dApps, Polkadot dApps. And I think the most unique part is what we call IoTT network, Internet of Trust Things, which is like a network for machines for different group of machines. So they are doing something different here. For example, we have UCAN as one group of machine, basically to let people to own their camera data. We have a PayPal as another group of machine. And most interestingly, we will have 3 or 4 teams actually on board in next quarter or so. Next slide, please. Yeah, so talking about the blockchain, yeah, like I said, fast EVM compatible, built from scratch, which has been running by 100-ish delegates worldwide for almost 2.5 years, I would say, and processing like 12, maybe 30 million transactions already. As you guys can see, the curve actually goes up recently. I think we are on the verge of getting this hockey growth very soon. The upcoming 1.2 mainnet release will also be compatible with Web3.js, and also we are onboarding different dApps from Ethereum ecosystem like Truffle, MetaMask, Snapshots, the Graph, OpenSea, and Polygon and Centrifuge, of course. Next slide, please. Yeah, so this is like a most interesting part we built on top of the blockchain. It's called the self-sovereign machine protocol. So it has different components. We have decentralized DID for machines and their owners. We have embedded SDK, which will be running on top of the machine. And we have a DAO, which is a set of contracts basically to manage the ownership, ownership management, some MEV exchange definition stuff. We use this DAO. And under the embedded SDK, we have an access control management framework, for machines to emit their data to the backend. And of course, storage backend, that's where we have lots of partnership with you guys who's sitting here today, like a Bluzelle, IPFS, Filecoin. I think you guys are our partners. Google, AWS, of course. Storj, of course, not yet, but I think definitely we should. So that's about self-sovereign machine protocol. Next slide. Yeah, cross-chain, I think it's kind of straightforward, so I will save some time here. But basically, IoTeX, we want this MEV extracted also like a floating around other blockchains. So that's why we have IoTube connect IoTeX blockchain to BSC, Binance Smart Chain, also connect to Ethereum, and we will be connecting to Matic in about probably a few weeks down the road, and also Polkadot we are thinking about too. Next slide. Yeah, that's kind of like an overview of IoTeX ecosystem, and we work with different exchanges, we work with different developers, we work with different enterprise like IEEE China Mobile, Nordic, IIC, and we have like a different type of stakeholders. Some of them are delegates, some of them are investors. Yeah, that's kind of like a huge view of IoTeX ecosystem. Next slide, please. Yeah, so that's where I want to spend a little bit more time on is this most unique part about IoTeX is what we call IoTT network. So basically it's a big network of machines, different group of machines serving different purposes. As of today, we already have 3,000 like machines working with, on this IoTT network across 55 countries. Next slide, please. And most of these machines are actually UCAN, which is what I'm showing here. So this is a project we work with a hardware vendor actually 2 years back. So it's like a normal 1080p, like a HD video camera, smart home camera you can purchase on Amazon right now and put in your home. But what makes it so different is this unparalleled security and privacy. So this is like a Web3 vision directly applied to an IoT device. Everybody can use, everybody can enjoy, right? So it has decentralized identity, it has end-to-end encryption, it uses confidential computing to do the object detection without invading your privacy at home. Everybody, of course, don't want to leak your home video data to some other cloud providers or maybe manufacturers for sure. So that's why we also have this user-owned storage. So yeah, UCAN is a huge success. It has been deployed to 3,000-ish like North American families already and still keeps growing. So we are thinking about like a UCAN 2 down the road. But this is so far the biggest group of machines which is stay on the IoTT network. Next slide, please. Yeah, so another group, which is also very unique group of machines that's going to be on board onto IoT network is called Pebble. So this one is very interesting. It's basically like a trustworthy, like a GPS tracker with, of course, 6-dimension different other trackers that collects the real world data from the real world, sign the data in a verifiable way, and give the data back to the blockchain, of course, the storage backend as well. We do like work with different teams, like probably 5-ish already. So they are working on something very different. For example, 2 teams, they are working on the real world NFTs for this proof of presence. So one team is called the Paper Go. It's kind of like doing like a Pokemon Go type of game on top of this like paper tracker. And another team is called Travala. It's probably like the biggest website, allow people to book flights and hotel using crypto so far. So they also want to use PayPal to do this proof of presence, like you have been to this place, so you enjoy some sort of discount or maybe points, so on and so forth. And another very, very interesting example is is we work with a team, so they want to do some weather derivatives on top of PayPal. Basically, PayPal has a weather sensor, so it can sense the weather, like a humidity, like a temperature, so on and so forth. And this team wants in a DeFi way, of course, so people can trade on weather. That's kind of very interesting one as well. Next slide. Yeah, so we have done the pre-sale for North American on cross-supply, which is the leading platform for those open source hardware kind of pre-sale. We sold roughly 600, among 40 plus countries, but most of them are here in Canada and the US. And we do have 200-ish developers who showed the interest, to purchase this one and to do some different things on top of this one. And we will open the pre-sale for Asian people, for Europe people very soon. And we hope we can launch this kind of real world mining proof of presence DApp in about end of Q3. Yeah, so next slide. Yeah, that's all about IoTeX. Very short intro about IoTeX. I'm sure there will be lots of interesting things if you dig into our website, our Twitter, and of course, if you have any question, just give me an email or maybe a sum up at Twitter. We'll be happy to talk. Thank you.
Thank you, Raullen. So I think that's a good summary of how we can do Web 3.0 in the IoT space. So I think Web 3.0 is more than just humans, but also for all the trillions of smart devices out there. So thank you, Raullen, again. And I'll now move to our next speaker, Dietrich. So Dietrich is the ecosystem lead for the Protocol Labs, IPFS. And before that, he was working on Mozilla, one of my favorite company. That's because the foundation that produced Firefox and many other useful things. So let's have a warm welcome to Dietrich to join us. And Dietrich, please go ahead.
Hey, thank you, Bruce. Also, thank you to Raullen for introducing me to NKN and NKN for hosting this event. It's very cool to see these different projects. So like Bruce said, I'm the IPFS ecosystem lead at Protocol Labs. I've been at Protocol Labs for a couple of years, and before that spent over decades building Firefox and Firefox OS and doing a number of other different things in Mozilla ecosystem. And it's very important to me that these technologies that we are all working on in our projects here in Web3 space are bridged and are able to be accessible in the mass web audience. And that's something that I work very hard to do and work with a number of partners. I'll talk a little bit about that in a moment. But I'm part of Protocol Labs. Protocol Labs is a research and product lab. So we do a lot of research and development. We also build protocols, and we also build and support ecosystems, building products and applications and businesses on top of these protocols. We have a couple of projects you may have heard of. So IPFS, the interplanetary file system. I'll talk a lot in this very short talk about the things that we are doing in that ecosystem, the different partners that are building on top of the technology and how it's used, what they're using it for. Filecoin launched last fall, and this is our incentivized way of putting data onto the network and incentivizing the long-term storage and building applications on top of a cryptographically verifiable and independent marketplace. So instead of AWS or Azure or something like that, as Bruce was talking about earlier, be able to have a choice to build your business and be able to store your data, whether personal or business, for the long term that you have control over, and it doesn't require a commitment to a single company to be able to do that. Both of these things are actually built on top of libp2p, which is a network stack that is transport agnostic. So it means with libp2p, you can build applications, you can build complex services and coordinated services without having to worry so much about what the underlying network capabilities of the device or the environment that you're operating in actually are. It abstracts that complexity away so that you can focus on your data and on your application logic. Both IPFS and Filecoin are built on this, as well as a number of different protocols and applications. So what is IPFS? IPFS is a content distribution protocol. Think of it like HTTP with maybe some of the bugs fixed and some additional features. One of the biggest and most unique characteristics of IPFS is that you address things by their content instead of by where they are on the network. This means that you add a file or you add some data to IPFS. The address that you get by which you refer to that on the network is unique to that set of data. If you change even one pixel in a photo that you added to IPFS is a new address. This means a couple of different things. Cryptographic verifiability is built into the protocol, and that percolates to every aspect of how you work with IPFS, developer workflows, what kind of assumptions that you can make around what data is and whether you can trust it or not, and removes man in the middle and other types of meddling with data on the network as a problem. It's also when you can verify that what you asked for cryptographically is what you get in return, you also no longer have to care who you got it from. And this is a really big difference from the trust model of the web, where who and where are very, very important pieces of that trust model. When you don't have to care where you got something from, you can get it from your neighbor, you can get it from other people in your local geography of the network, or you can get it from all the way around the world if only somebody over there has that data. If the original site went down that was hosting the data, it still might be available on the network. And this is something that is really a resilience add to the HTTP web that we are used to today. And finally, that means that we also have different ways of thinking about trust. And in this space, we talk a lot about trustlessness. I think there are a number of different ways that trust manifests itself as a user need. And right now, the HTTP web has one size fits all trust model, which is the nexus of SSL, DNS, and HTTP. And it's coded very strongly into that nexus such that you can't really change what your trust model is. But the trust model that I have with a remote website is really different than the one I have with my daughter or with my friends or with my business or my business partners. So with this stack, a lot of the projects that you're seeing today, not just IPFS, you're seeing new trust models emerge from these primitives that we have in these systems. So let's walk through a couple of different users and use cases. Right now, like 404s are a household term. Even non-technical people know what a 404 is. This is really a big problem on the web today, where I think the window of human experience is being created onto the web and then destroyed, or moving into walled gardens that we can no longer access in a pretty big way. And with networks and applications built on top of things like IPFS, the data stays around a lot longer. HTTP web was also not built for offline use. Offline capabilities are bolted on. Some of them have come and gone, like app cache. Some of them are really hard to develop for, and some of them are still waiting for web engines to adopt them. But with IPFS, we've really flipped the model where the data store that you have locally is the center of the activity, and the transport is a side effect to that. Whereas HTTP, the transport is the core of the network application, and the publisher has total control over that data set. So offline applications work by default, and local first applications where you can interact with somebody over a BLE or a local network without even internet access also works. And censorship is a major issue, and I'll talk about a couple of those use cases in a sec. But one of the biggest uses of IPFS in this space is for off-chain storage. The immutability of content addressing means that IPFS is a very powerful tool for blockchain-based applications and for dApps of all kinds. And this is really the place where we're seeing a lot of uptake in terms of distributed applications, NFTs, and a number of other places where people are using IPFS because that immutability provides from its root a resilience that other storage applications cannot provide. Identity is one of these places where we're working with projects like Fission, Ceramic, and 3Box, Ion, which is Microsoft's decentralized identity infrastructure that is using IPFS and the Bitcoin blockchain, a protocol that's usable by anybody, and interestingly, doesn't require you to use Microsoft Service to be able to use it. We're going to probably be seeing more of these types of IPFS-based identity solutions moving forward. Decentralized naming, so things like ENS and unstoppable domains, using DNS to be able to refer to off-chain data, or to be able to check the blockchain first, to be able to then direct you to IPFS resources, is a pattern we're seeing. COVID news, unsurprisingly, access to critical health information is something that is being restricted in several places around the world. Most recently this weekend, lots of stories about India restricting that data, and even working with companies like Twitter to take critical COVID news off of public social networks, which shows that maybe they're not as public as we thought. Wikipedia, with what's going on in Myanmar right now, one of the first things they did was take a number of websites offline, and then also take large chunks of the internet offline and internet access away completely. But we worked with human rights groups in Southeast Asia and some communities on the ground there to make sure that the Myanmar localization of Wikipedia was up on IPFS, so that it was still accessible for so many places in the world. This is critical information for these communities. Physical and digital goods. We're seeing IPFS-based stores showing up in a number of different places. And most recently, of course, with the NFT explosion over the last couple months, we've been very busy because a lot of the NFT solutions use IPFS for asset storage. So we are really focusing on what are the best practices for using IPFS for NFT storage, for metadata storage, and for ensuring the ongoing and permanent availability of NFTs, and for these services to be able to correctly use addresses to ensure that these assets still belong in whatever, or are certified in whatever form that means for you, for NFTs, to the person who paid for the token itself. DeFi explosion. Last year, lots of these sites using IPFS, both for the data, off-chain data, but also using it to host their front ends, which is kind of a fascinating thing, right? Where you have a trustless front end for a financial application is really, really interesting pattern we saw a lot of. We went into depth on our docs website to be able to provide more in-depth stories around how some of these projects have built what they have built. You can find these case studies on our website. Netflix was using IPFS for experimentation with container distribution. So a global network at the edges in a bunch of different places that all need to be able to get new containers, OS updates, and content updates on a regular basis inside that virtual private network. You don't care where things are, and you trust all the nodes in that network. So it became a powerful tool in this experiment to show that, one, IPFS was performant enough to be able to do that, and two, how the complexity and overhead of location-based addressing, once removed, made the overall architecture simpler. Audius, with the audio token, a decentralized IPFS-based Spotify, where not only do artists have more power, but even players just listening to music allows you to earn and be part of the network. And Ethereum too, using libp2p at its core as the networking infrastructure for us, supporting these use cases really strong. And again, an example of where some of those tools that we're building at Protocol Labs are not just IPFS and Filecoin, but supporting other larger ecosystems as well. Really a lot of projects in this world. But I want to talk a minute too about web browsers. That's the world that I came from. We worked with Opera to add IPFS support to Opera Android last year, Opera Touch at iOS this year, and then Opera Desktop, currently in beta. You can download Opera Developer now and get IPFS support there. And one of the big announcements this year was culmination of long work that we did with Brave to integrate a full and true IPFS node. So with Brave today, if you go to an IPFS address, it will prompt you. You can hit OK, and it will install an IPFS node and manage it for you, and actually run that locally. And with Brave, really an accomplishment in growing a user base in a very, very tough and market dominated by major players like Chrome. Very exciting times to work with a browser that is taking these steps. Quick couple of words about Filecoin. We launched Filecoin last yeyear. Filecoin nodes are IPFS nodes and use IPFS technology, but also have a blockchain, whereas IPFS does not, that allows the crypto economic model and the incentivized storage of data, both IPFS or not IPFS data. Lots and lots of projects building on Filecoin right now, and including that often use IPFS. And you can go to storage.filecoin.io to see numbers about the activity that's happening on the network. We're seeing some really interesting use cases of this storage, especially around sensitive data that needs to be verified. You're probably going to hear a lot more about Filecoin being used for situations where you have multiple parties that need to cryptographically verify data that's stored securely. And finally, I really would just want to end with a new service that we launched over the last month. It's currently in beta, but you can use it today, which is nft.storj. So this is a website that allows you to use HTTP APIs that your tools, your IDEs, and your developers are all familiar with to be able to put NFT data and metadata onto both IPFS and Filecoin. This is a free service. It's going to keep NFTs, assets, and metadata available and highly available. We're working with a number of partners to make sure that this use case supports that community and their needs extremely well over the coming months as adoption really, really grows at a high rate. So that is a quick speed run through IPFS ecosystem, some of the Filecoin work that we're doing right now, and how we're supporting the NFT community. You can find IPFS and Protocol Labs and all the usual places. But one thing I did want to tell you to check out is Protoschool, proto.school. It's a website that has foundational explanations for some of the primitives that we're using in all of these Web3 applications, not just IPFS. And it's well worth looking at if you're onboarding into the space from the Web2 world. Thank you very much for having me. Happy to answer any questions in the chat.
Okay, thanks, Dietrich. I'm really happy to see the IPFS presentation because I think IPFS is probably the granddaddy of all the decentralization technology. And because you talk about all the use cases starting from the Wikipedia all the way to the latest NFT. It's amazing how much developer ecosystem you already built over the years. So we all can learn something from protocol.school and also as a project, I think we can learn a lot from IPFS. Thank you a lot, Dietrich.
Thank you so much.
Thanks for joining us. All right, with that, we'll go to our next speaker. So we'll have Yilun from NKN, CTO of NKN. And he has been doing some interesting research in university about computational neuroscience. And he's a full stack developer. And let's welcome Yilun for the next presentation.
So hello, everyone. I'm Yilun. So Bruce, do you want to share the slides or I share the slides? Sorry, you're muted.
You can go ahead. You can go ahead. Yeah. So if it's
Okay.
more convenient for you.
Can you see my slides?
Yes, very well.
Okay. I'll start. So hello, everyone. I'm Yilun, co-founder and CTO of NKN. So today I'm going to talk about the Web 3.0 in NKN and how we develop the applications on top of NKN. So this talk will be a little bit like developer-oriented. So basically, there are three type of typical resources if you want to build an app. So like the compute resource, the storage, and the network resource. So what NKN does is that it focuses on the network part and trying to provide a decentralized network as a service. So 2 weeks ago, NKN has surpassed like over 100,000 full consensus node into its network. So here you can see that our node count actually increased or explode in the past months and increased from 30,000 to 100K in around the month. So these are not just like light client. These are all full consensus node participating in the consensus and doing the relay, providing network resources into the network. So if you want to, if you use NKN client, it will connect it to one or several of those nodes and use them as like the relayer for you. So it is currently the largest, NKN is currently the largest blockchain network in the world in terms of the node count. our next target is 1 million nodes, and we really hope that we can reach that point soon. So imagine how much you can do with 100K servers in like as a traditional in a traditional app, right? So the next part for us to do is to how we can utilize that 100K nodes well and provide like good SDKs and attract users to use the app to utilize the network. So basically what NKN provides is a decentralized peer-to-peer communication. And so think of it this way. Traditionally, if your phone wants to talk to another phone or like a laptop or a NAS device or a Raspberry Pi, whatever in the application, you typically has a server that is in between, and both are connected to a server that is provided by the app developer, and they talk to each other through the server. What NKN provides is a similar experience, but in a decentralized way. You don't need to provide, the developer doesn't need to provide any server or set up anything. They just embed NKN SDK on both sides, and then they can talk to each other directly using the NKN address. So all the data are transmitted off-chain, so it's network layer latency, like 100 milliseconds or so. And also we use NKN address, which is basically a public key with some like identifier instead of the IP address. So it basically hides your IP address, and also it's static and it's network agnostic. It doesn't change whenever you are. So, and all the data are transmitted through NKN end-to-end encrypted, of course, because we already know the public key of the receiver when we want to send a message. And we have the free relay mode and also the paid session mode, where you pay the relayer the NKN token based on how much data it has been relayed for you. And one of the most, I would say this advantage in the blockchain world, but it's quite common as a for non-blockchain developer, is that our SDK does not require any prior knowledge on blockchain, on smart contract, on token, on crypto, anything. It's just like a normal like web SDK and or whatever SDK that developer can just grab and use. And we actually provide it in a lot of language. So it's easier to just look at the example. So here is a minimal example in JavaScript. Basically, if you want to send a message, you just need to create NKN client, and then you can send the message to another NKN address. Or if you want to receive the message, you create a client and you can receive the message immediately. And also we have like session mode. You can dial a session to another NKN client or accept a session. So it is basically provide the same API and features as a TCP connection. So here I'm going to show you one of the case studies of the N-Mobile. So N-Mobile is a decentralized IM that we are developing in-house. So it's basically, you can think of it as like a decentralized messenger, decentralized WhatsApp or something. We designed it from scratch, completely from the decentralized, with a decentralized architecture. So initially, we actually thought about trying to adopt some of the popular instant messenger and try to make it decentralized. But we find it's just hard to do it because in the decentralized architecture, a lot of things are different from the start, and you kind of have to do it completely different in a completely different way. So basically, when you are chatting with your friend in a WhatsApp, you are both connected to their server or server cluster, and your chat history is stored there, and a lot of the business logic are stored there. And the phone is it's most of the time it's just showing you what's happening. But now, if we want to go decentralized, we kind of have to take out that server part and use NKN as transport layer. So basically, all the data, like the chat history, goes to the device side, and all of the business logic goes to device side. So there aren't many features that you cannot implement this way, but it's just a little bit different. So here is by going decentralized, we have a few advantages, right? So first of all, we don't need to worry about the backend. We don't need to develop the backend code and put additional resources, either human or like machine resources there. And there's no single point of failure as long as the NK network is like reliable enough, which is. And also we have better security because there's all the data are end-to-end encrypted using the like end-to-end public key, and there's no server that can access any of this data. So basically, there's no single point where you can just crack the server and get all the data or get all the like users' data or something. That is just impossible. So even if you crack one of the device or you somehow get its like private key or like user's password, you just crack that data on that device. There is no effect on the other users. And also, as long as so if you develop an app in a decentralized way, you don't need to worry about scalability, because as long as the underlying network layer can like handle it, it just scales naturally. But there are also some challenges if you want to go this way. And so first of all, we have to design a more complex protocol, because previously we have like central point which can control everything. But now, if you want to implement all those features from the end device, you still can do it, but the protocol needs to be a lot more complex, considering a lot more things in order to do the same thing. And also, the environment is less controllable because you don't have a central point where you can completely control and reject things if you find things go wrong, right? There are people running old versions that you cannot force them to upgrade. There are people modify the code trying to do something, and you can just tolerate it and make it work in your app. So those are kind of, I would say, pretty common challenges if you want to build a decentralized app. And they are all solvable, but just it's kind of different challenges from the traditional app. So another case that I want to show you is NConnect. So NConnect is basically a transparent end-to-end tunnel that allows a device talk to another device as if they are in the same local network. So think of it this way: if you have a NAS device at home, and then you can access all this like storage and photos, videos when you are at home, right, in the same Wi-Fi network. But if you're outside and if you want to connect to it, you typically need some kind of like either relay service or like reverse proxy or like VPN or something. So this is what basically NConnect provides. So as long as both sides has NConnect installed, they can create a tunnel, and they are all the applications can work as if they are in the same local network. And there is no need to modify any of the application. It's actually transparent to them. So there are like two modes. So the free mode is using the relay, the NK network, to relay the message. And also we have the paid mode, where one of the party finds a service provider in NK network and create connections and ask it to relay the message for it. Then you actually use NanoPay to pay for the data you use on that relay server. So by doing this in a decentralized way, we again have some advantages. Like it's network agnostic because we don't use IP address, we use NK address, which is like static wherever you are. And also we have top level security because there's no server and everything is end-to-end encrypted. So basically it's just uncrackable according to the current like technology. And also we can, one of the unique advantages that we can, as a overlay network, we can aggregate multiple different paths and get higher throughput. So that's some of the advantages, but also we introduced some additional challenges. So one of the challenges is that it's pretty common for any blockchain like business model. So how we can onboard paid customer that does not have any token or knowledge of blockchain. Because, well, we have this famous joke that if you want to buy a drink using some token, you kind of have to do register for account on the exchange and do a KYC and then buy some, like put your initially like a bank transfer, and then buy some, after a few days you can buy some like big tokens and then like BTC and then use that, or USDT, and then use that to buy the smaller token you want. Well, this is just unacceptable for like a customer facing applications. So what we end up with doing is that we provide a portal that accept fiat payment and hide all those token details. So user just know that, okay, I spend this much dollars buying this amount of like data, and then they can just use it. And they don't need to know anything about the token. And we believe that is kind of the only way if we want to gain mass adoptions, like to billions of people in the world. And another technical challenges that we are facing is that without a server, we don't have any control of the quality of the service. So we kind of have to do it. It's still doable, but it's kind of harder to select the good servers on the user side. And we end up with using a lot of effort trying to do it, trying to find out the good servers with good quality and measure it performance. And if we find out it's like just not satisfying, we just drop the connection and change to another server also. So the last but not least case that I want to show is a search by our community team, Rule 110. So it is basically a P2P file sharing app like a BitTorrent, but it's anonymous, it's end-to-end encrypted, and it's decentralized. So it's using the same technology as NKN tunnel. So basically all the traffic are going through the NKN network, and you don't need to like expose your IP address or like expose what kind of traffic you are putting into the network. So it is pretty an amazing app, and we believe it has a huge potential. So here's a summary. So basically, what NKN enables provides a decentralized peer-to-peer communication suite. So it is network agnostic, and because we use NKN address instead of IP address. And it also has top-level security. All the data are end-to-end encrypted. We are not exposing IP address to end users. And also, we have this freemium model where you have like free relay mode or like the paid session mode. And also, it is important that to use NKN network, it does not require any knowledge on blockchain, on token, on crypto, or anything. Just any developer can use it. And there are quite a lot of case that I want to show more, but since the time is limited, maybe I will show it next time. So yeah, that's it. And thanks everyone for your time.
Okay, thanks, Yilun. So I saw the three examples you gave us. They all kind of could be used some kind of decentralized storage solution as well, right? So I think that's also kind of we look forward to do some mashup and collaboration with IPFS, Storj, and Bluzelle. So how can we add some kind of persistent storage either for the messages or for the files, etc. So
yeah.
Actually, about 2 years ago, we did that mashup. We did a proof of concept, but I think it's time to in the new context, in the new environment, we can try it again. Yeah. Okay. Thanks, Yilun. So because of time, we have to move on and to our next speaker. So we have Kevin from Storj. So Kevin is a partner manager and solution architect, and he will talk to us about the decentralized cloud storage, or DCS. I think Storj has a very clever way. So they hide some kind of complexity from the developers so they can migrate smoothly from existing cloud provider like AWS to their DCS solution. So it's a very clever solution. So I welcome Kevin to give the presentation. And Kevin, please.
Sure thing. Thanks, Bruce. It's really exciting to be here again for my second time presenting at the NKN Summit. A lot has changed since 2020 when I presented last year, and I'm excited to walk through some of those updates with the community today. So let me go ahead and share my screen and pull up my presentation for today. There we go. Then I think if I make this full screen, yeah, that should be good. Excellent. So let me just set up here one more thing. And while I get started here, we had some really awesome announcements just last week. We basically migrated Tardigrade, which was the brand that I spoke about last year, over to a new brand called Storj DCS. And so Tardigrade was the name of the developer tool that developers use to upload and download data to the Storj network. And we basically made the decision to rebrand that into Storj DCS, which stands for Storj Decentralized Cloud Storage, and is a tool to make it really easy to migrate from existing solutions like Amazon S3 and any S3 compatible solution, whether that's Backblaze, Wasabi, or Amazon, to Storj. And so what's really interesting is that as part of this launch, we actually launched a globally distributed S3 gateway. So based on some feedback from our customers, we found that many people didn't want to run a gateway locally. They didn't want to host any software. They didn't want the DevOps overhead of like running that software. So we just launched a hosted, globally distributed gateway service called Storj Gateway MT, which originally relied on the Minio code. We rewrote it from scratch to make it multi-tenant. And that's something that we're really excited that we just launched last week. In addition to new pricing, we're now really 1/5 the price of AWS US East. We were previously 1/2. So we cost $4 per terabyte of storage and $7 per terabyte of bandwidth, which is really exciting. We think that these new prices are going to be really exciting to developers and help accelerate migrations to the decentralized cloud. And so last year when I was here, I talked about all the different
Kevin,
Yep.
Kevin, sorry for interruption. I think we did not see your slide moving.
Okay. Do you see it now?
Okay. Yeah. Now it's moving.
Getting
Good.
started here, moving to the agenda. So last year when I was here, I talked about the various integrations that we had with tardigrade, which are now all available on Storj DCS. And so we talked about the native distributed database snapshot tools that work for databases like MongoDB and Flurry. We talked about our Kubernetes strategy using Valero, which is a VMware tool to back up etcd data and persistent volumes. We talked about rclone, which is an rsync-like experience. And then we talked about different backup tools. Today, I'm going to talk about what's new since we last spoke. But first, I'm going to talk about just a background here on what is Storj DCS. And so Storj DCS, again, we touched on it earlier. It's a more private, secure, and economical approach to cloud storage. And so really, if you've used Amazon S3, very familiar tool set. You create buckets, you put objects in buckets, you stream them and delete them. But critically, you don't have to worry about replications. So you don't have to replicate your data from, say, US East to US West to Europe, to the APAC region, to South America, to Africa, et cetera. Data is encrypted client side, broken up into redundant erasure coded pieces, and then distributed across the globe by default. So when you call that file, you're calling all these parallel streams that are just streaming the closest data to you. And then we talked about kind of the new pricing as well. So Storj, how it's different, right? For developers, we're automatically encrypted. So we implement erasure coding and AES 256 encryption, which is like military grade encryption. To basically ensure that only you have the private keys to your data. Much like on Bitcoin, your keys are your keys are your Bitcoin. On Ethereum, your keys are your claim to gas, computational power on the Ethereum network. On Storj, your keys are your data, and that's really that design principle that we're building around. And so even for sharing data, rather than using a centralized access control list, we use a construct called macaroons, which are these client-side bearer tokens that are made from hashed message authentication codes that enable access. So we're differentiated there. We're multi-threaded. So instead of a single thread of data from a data center, you're instead calling 80 nodes that are storing a general piece of a file. And the first 29 that bring you that piece rebuild your file locally. And so all these, you basically have a competition of all these different nodes that are streaming data concurrently. And then we're more flexible, more economical, really easy to use compared to a lot of other tools. And so the way that it works, there's a network of nodes. So we have tens of thousands of nodes spread across the globe that are sharing excess storage capacity and also excess bandwidth capacity. And we're using that to kind of create the foundation for this distributed storage network. It's important to note that like cloud data centers, right, maybe have like 6 data centers in the US, right, like 50 across the country. CDNs are an order of magnitude larger. There tends to be about 1,300 points of presence for CDN. On Storj or on decentralized cloud, we actually have another order of magnitude higher distribution. So today we have, I think, 12,000 nodes spread across the globe and growing, which is another factor of 10 increase over traditional CDNs. And then basically developers create applications that talk with Storj, either using our native Go library or using that S3 gateway for just ease of use. So there's really 2 patterns: either go through the gateway to migrate easily, just to get to market. If you're using S3 today, it's a really easy integration pattern. Or if you want native parallelism and all the advantages of client side, you'd basically integrate with our Go library. And then the satellites store encrypted metadata. They basically store the path. So rather than having to go through a Kademlia-based discover process where you go, hey, do you have my file? And the neighbor goes, no, but let me talk to all my neighbors, see if they have the file, and then it kind of fractals out so you find the file location. We know where all of your data is stored. The network knows where all of your data is stored. That metadata is encrypted and also cached on a node called the satellite. So you always have that routing information of how to get to your data quickly. And then we eliminate that Kademlia discover process, which can really slow things down. We have proven capacity, proven customers, proven partners, really great team. Our CEO is the former CEO of Docker, which was the largest open source community behind Linux, right? He grew that at the time and now is leading Storj. Our CMO comes from Twilio and SendGrid. So we have a really great leadership team and really great partners and customers today. We have over 11,000 node operators in 85 countries. Over 200 million objects are stored on the network today, and we've never lost a file. So we have 11 nines of availability, of durability, and we offer that through an SLA. And so if you work, right, basically if you pay with credit card and you pay through Storj and you do an enterprise contract, you should get an SLA guaranteeing the availability of and durability of data, which is interesting. There's actually a really good thread about decentralized storage and Hacker News, and the question of SLAs came up, and just it's important to note that we do offer SLAs. We work with the leading open source companies, so we have native integration for FileZilla, which is the leading FTP tool in the world today, and so you can natively leverage decentralized cloud storage as an origin for FTP on FileZilla and transfer large files point to point in a highly parallelized manner. We work with all these open source database companies. Nextcloud is an open source file management tool, kind of like open source Google Drive, for example, and you can actually store all of your S3 related assets in Storj and have a file management type experience using Nextcloud. Plesk is also works, I think, the owner of cPanel as well, and they basically power all these web servers across the world, and we have an interesting partnership that we're announcing with them again today too. So next, we're going to talk about how you can upgrade your stack with Storj. How is Storj differentiated? If you're a developer, why do you want to use Storj? One of the really cool things we announced today was gRPC, which enables you to upgrade your messaging stack. This is a complete rewrite of gRPC, right? The general purpose, Go file. And so, we found that, 81% of heap usage was through gRPC. So it was really bloated. So basically to power this distributed network, we decided to rewrite gRPC in a way that's much more efficient in terms of resource utilization. And we just published our benchmarks on GitHub today, so I'd recommend checking that out. The whole thing's really simple to use. It's under 3,000 lines of code. gRPC is over 30,000 lines of code. So that's a really cool messaging tool that we announced today and we open sourced. You can upgrade your stack with that. Another cool thing that I wanted to bring up was our integration with ZK Sync. So ZK Sync is built by Matter Labs. It's an L2 implementation of a zero-knowledge rollup on Ethereum. And so essentially what you're doing is you're creating first a circuit, then a generalized virtual machine using series of zero-knowledge proofs that are rooted in the blockchain. So they maintain the security and data availability of the blockchain, but then you're running compute and storage off-chain, but you're creating this zero-knowledge circuit that verifies the whole thing. What that's enabled us to do is scale our payments up really rapidly. And so with ZK Sync, we're capable of 2,000 transactions per second. So, ultimately we're looking to move a monthly model, make it look, more instead of a discrete function, make it look more like a continuous wave function is what we like to say. This also, has much lower fees, in terms of GUI or gas on Ethereum. It's less than a penny versus like a $20 transaction on the mainnet. And then it also enables us to pay network fees in Storj. So that has kind of a native thing called gasless meta transactions where you can convert, the Storj token to pay for the gas on Ethereum through DEX. So it's a really easy, really cool integration that we've implemented. And we've seen a number of our Storj nodes opt into it already today. And we're kind of continuously innovating around this area of smart contracts and payments on Storj as well. So I wanted to first talk about our innovation, our distributed systems, then talk about our innovation in the blockchain space. Next, what I want to do is talk about some of our partner case studies and some new solution architectures that we're seeing developers use to basically bring real world value to the decentralized cloud through some kind of real life app stack. The first one is Fastly. So Fastly is probably the fastest growing and one of the more innovative content delivery networks that is in the market today. Fastly is the CDN for TikTok. And so really what this means is that Storj can act as the origin for Fastly's edge network. And so if you have an application, a mobile application where you want the kernel of that storage to be decentralized, but you want TikTok level performance or throughput at the edge, you can do that with a Storj Fastly integration. And so, you know, there are all kinds of really cool application stacks that get opened up because of that, right? So obviously storage is natively distributed. And so because of that, right, it's really well suited for a distributed edge network for compute and CDN processes. So this is a partnership that we're really excited about, and enables kind of a whole new class of applications that want to, you know, a decentralized kernel that's also much more economical than, you know, a centralized cloud provider and has better bandwidth egress fees, but then is also, right, has that ability of throughput at kind of the TikTok level of performance. Another really interesting partnership that we launched last week was with Plesk. Enables you to back up your web servers or take snapshots of your web servers and store those on the decentralized cloud using their S3 native S3 backup function. Right today, Plesk runs on more than 384,000 servers. They automate more than 11 million websites and 15 million mailboxes. And so we think that this solution pattern, right, is using encryption to offer just better privacy, better edge-based access management using macaroons, superior security for Plesk users. So this is a use case that we're really excited about that we announced last week. We also have a partnership that we announced with Filebase recently. Filebase is another S3 compatible tool that enables you to connect to the decentralized cloud. They cache data at strategic locations across the globe to try to increase performance. And you can natively leverage Filebase to store data on Storj if you so wish, to do that in a way that doesn't require API keys or, you know, it basically simplifies that process of connecting. We've launched a bunch of customers this year, most of them through the Tardigrade brand. But one that we're excited about that I wanted to highlight today was PPE Exchange, which is a personal protective equipment exchange that was delivering PPE equipment during the COVID crisis. They were able to store snapshots of their Hyperledger instance using the rclone connector with Storj, and also snapshot or cache their MongoDB database as well. So they used really two cool partner integrations to develop a solution that created value for them. Making, you know, basically we're able to lower their cost of cloud storage, increase like the efficiency of their tech stack, and increase the resiliency of their tech stack by having, you know, more of a distributed storage origin for all of their database snapshots and Hyperledger snapshots. That's one cool customer. We have a bunch of other really cool ones on the blog. So I really recommend going to storj.io/blog and following us on Twitter @Storj to stay up to date with all of the customers, partners, integrations, and all the fun that we're having on the tech side in 2021. You know, as a next step, you can get started with Storj, storj.io/sign up, generate an API key, and then start uploading data to the decentralized cloud. Again, it's designed to be easy to use. We're really excited about our new launch, and we are always looking for community feedback around how we can improve the product and service as well. And so with that, I wanted to say, let's free the cloud. Let's free our object storage by leveraging the power of decentralization. Thanks again for having me on, Bruce. Appreciate it.
Okay. Thank you, Kevin. I think I'm very impressed how many customers you already lined up for your DCS solution. And but I think beyond that, the most exciting part is actually renamed, because the tardigrade is kind of acquired taste. I'm glad you changed to Storj DCS. For the people in the audience, you can Google what is tardigrade later on. But now we have to move on to our next exciting presentation by the CEO and the co-founder of Taxa. Thanks again, Kevin. And so please, let's move on to the next speaker.
Thank you.
All right, so thank you. The next one is TF. TF is the founder and CEO of Taxa Network. And he actually has been a Bitcoin blockchain believer since 2014. And he's a very young person, so I guess must be very early kind of adopter. And so let's hear about what he's been doing with Taxa Network and what exciting things are coming up in the decentralized computing space. Please go ahead,
Thank
TF.
you, Bruce. Yeah, hi everyone. This is TF, co-founder of Taxa Network. And thank you, NKN, for the invitation. Yeah, and today I'm going to introduce you the interactive Web3 services we are bringing to the Web3 ecosystem, and also about our vision for a layered architecture for the future DApps. And let's begin with a question. So computing and storage are two cornerstones for the future Web3 ecosystem. And for storage part, we already have like IPFS, Storj, and Bluzelle. Well, today, most of the DApps are building their computation, in other words, business logics, based on smart contracts. However, the trustlessness of smart contracts comes with a high cost. It's not about scalability. It's about what an individual smart contract can do compared to the Web 2.0 services. And I know this is not a fair comparison but it does show the trustless trust comes with a cost on performance. For example, time and space resources. And because of the consensus mechanisms, you cannot run complicated computation. Although Ethereum is known as a world computer, but computing is not its specialty. And if you try to do complicated business logics or a certain amount of input data will cause a very expensive gas fee. And also about functionalities. The smart contracts are mainly built for the transaction-based business logics. And also the response latency is also because of the consensus mechanism. And also about privacy. Privacy, is actually contradict with blockchain's design principle. So blockchain is built for transparency, not for privacy. And the privacy protocols on layer 1 usually come with a high cost on performance. And Taxa network is designed with a layered architecture philosophy. So the idea is, why are we couple everything on layer 1, both computation and the state? And the Taxa network will move the smart contract execution to the middleware of the blockchain, put the smart contract off-chain. And instead of using consensus mechanism to make sure the business logic is tamper-proof, we use the trusted execution environment off-chain to guarantee the node will not be able to tamper the data and the code. And also, we guarantee the confidentiality of the smart contract. And in our vision, the future DApp will be in a layered architecture. Each layer will do what it does the best. The middleware Taxa network will be focusing on the high performance and privacy preserving business logic. And the layer 1 blockchain does what it does the best, which is providing the immutable persistent state and forming the consensus. And the relationship between Taxa network and a layer 1 blockchain is a little bit like a backend service to a database. And let me introduce the smart contract running on Taxa network. It's called trusted service, T-services. And T-services, by using the trusted execution environment technology, we achieve 3 things altogether. First, the privacy. Second, computation performance. And third, the Turing-complete programming language. And also a little bit different from the on-chain smart contract. We are interactive. That is benefited from the off-chain feature. So instead of waiting for the confirmation, there's no confirmation needed. It's based on a response-based protocol. And also, we are not a blockchain, and the T-service is by default stateless. But we do provide a short-term storage mechanism that I'll introduce later. And the benefit using T-services, first, is about computing performance. Currently we support 8 megabytes of data input for each smart contract call, and 30 times timeout, 30 seconds timeout, and providing much richer computing resources compared to on-chain smart contracts. And also it's interactive, no confirmation needed. And our privacy policy is opt-out, which means the data will be by default confidential unless the developer or user reveals it. And the code will be transparent and attestable. And for the developer environment, we migrated Python, an entire Python runtime environment inside the TE. Currently, we are using the CPU-based SGX technology. And the reason we choose Python rather than commonly seen like in Oasis or Fella, they use WebAssembly and Rust. The benefit of Python there are 2 benefits. First, the library support. Python supports rich functionalities, including especially in the computation, in the for the model computation and AI, big data. And also we migrated the blockchain related libraries such as the blockchain and cryptography protocols. And as an off-chain infrastructure, we are blockchain agnostic. Currently, all the smart contract systems supporting verifying the ECDSA signature are supported. Okay, enough for the concept. Let's go through a real example. The hello world on Taxa network is called the millionaire problem. It's proposed by Professor Yao. So the problem is, suppose there are two millionaires, Alice and Bob. They want to find out who is richer without revealing their actual wealth. So it's a very abstract of the privacy computing problem. And first, the entrance of a T service is identified by a URL. As you can see, the pink letter in the middle of the screen begin with Taxa. And that's the entrance for the T services for the millionaire problem. And the address part is a multi-hash of the code, which means if two users are requesting the same URL, you can guarantee they are pointing to the same code, and it's in multi-hash and IPFS compatible. And the user will attest the enclave inside the trusted execution environment node, and they will establish a AES key. So basically, they will do three things. First, verify whether the environment is integrity, and also to verify the code being executed inside the enclave. And then the user and enclave will establish an encrypted connection. It's very similar to TLS handshake. And so the node will forward all the traffic, but the node cannot receive any of the plain text data. And the data field is encrypted and can only be decrypted inside the enclave. And let's talk about the developing environment inside the enclave. So as I said, we implement Taxa, which is Python plus Taxa, and the user can develop it just like building the Web 2.0 applications, and with a rich library support. Also, we migrated additional blockchain protocols, blockchain cryptography related protocols in it. So here's the example for the millionaire problem. It's a very straightforward implementation, just like you're building a centralized service. You use you can handle the URL request using different functions. You can receive the user request data, and you can temporarily store them, and then use response to send back the result. And it's basically like a Web 2.0 application. The only difference is the data is confidential, which means the node as the service provider will not be able to see the confidential data submitted by the user. You can give the node your privacy, and the node won't be able to decrypt it. And the entire code is running inside of the enclave. And also talk about our layer 1 communication mechanism. So the question is, for example, if you can build a millionaire problem, you can build a lot of more things. For example, the games, and especially those information asymmetric games, such as a card game, which is also interactive. And well, after the game, maybe the two players want to play with tokens. So there will be certain transaction being generated to layer 1. And how can you guarantee a message is generated inside of the T service and is not forged? And that will involve signature. So the TE will be able to hold the securely store user's private key and do the computation on it. So the user, the user could generate a key pair, and the private key can be put inside the enclave to sign messages and authorize transactions. And the user can pre-authorize the payment on-chain using the public key. And then, for example, after the two players play the card game, and the enclave will generate a signed message, which can be later broadcast to the on-chain smart contract, verifying the signature and unlock the transaction. And also in our roadmap, we are planning to use Polkadot for the message broadcasting using cross-chain messaging system. And Taxa network will enable a lot of new use cases for blockchain, which involving interactive, privacy-preserving, and computational performance applications. For example, in NIT field, we can implement blind auctions instead of on-chain auctions, comes with a high gas fee, and also not entirely fair. And we can put the auction process off the chain, interactive and privacy preserving. And also game is also also contain a lot of use cases in the GameFi industry, especially those games with information asymmetric and also interactive. And wallet management, which uses the feature that TE can hold the private keys and to allow users to use in a more user-friendly way to manage their wallet without giving the ownership of their key to others. And also we can build coin mixers, and also identity authentication, which means the T service can just tell the authenticator yes or no without revealing the user's detailed privacy. And also collaborative computation, like everyone can borrow their data to others to compute a certain model without losing the ownership of their data. And some examples, for the time issue, I won't go through them in detail. The left one is one of a developer built prisoner dilemma game, which is interactive and also requires some kind of information asymmetric. So the prisoner dilemma, if you play it only once, there's a fixed result, always end in Nash equation. But if you play it repeatedly, there are some strategies you can use. And on the right is another application to solving the PSI problem, private set intersection. For example, the two service providers want to find which users exist in both of their database, but they don't want to leak the user's privacy. And or if you want to build a trusted service that you exchange your contact list with a stranger, find out your mutual friends, and it can be entirely based on web, and using a browser plugin to communicate with our network. And the experience could be totally similar as a Web 2 application. The only difference is the backend is trusted. You can guarantee the integrity and the confidentiality of your data. Yeah, that is all. Thank you.
Okay, thank you, TF. I think this is the first time I actually hear your presentation. It's very exciting, and I think you are in a launching phase, right? So we look forward to hear more news from you as well. So
yeah,
thank you, TF, for joining us today.
Network, and you can there's a guidance of downloading our SDK and building the T services.
Okay, thank you. So now we have completed all our presentations. So now we are going to the panel mode. And I believe Susie have already compiled I hope, a healthy list of questions for our panelists. So maybe why don't you go ahead, Susie, from the Q&A in the webinar. So if people on the webinar, there's a Q&A functionality. You can ask questions on the Q&A session. For the panelists, you can also look at the Q&A. If there's a question you want to answer, you can pick that. So that's the Q&A function. And Susie also has been working hard to collect the question from the YouTube live stream. So they have a live chat. So while the panelists look at the Q&A, preparing the answers, Susie, why don't you pick a few questions from the chat or the YouTube live, please?
Yeah, sure. Hi, everyone. This is Susie. Can you hear me well?
Yes, very well.
Okay, sure. Oh, so yes, I've been collecting questions. So first of all, can we start with Bluzelle, please?
Sure. So how are we doing?
Hi, Neeraj. Yeah, so we've got a question for you here. So from Siavash Tamurus, I hope I've got the names right. If not, I'm sorry. And so the question is, what is the max TPS on your NoSQL database? Can it be scaled horizontally?
Yeah, so that's a good question. The TPS that we have advertised, I don't remember the exact numbers, but yeah, I believe it was 10,000. And yes, it can be scaled horizontally. Currently, the way our network is architected, we're not scaling horizontally. It doesn't mean we cannot. So in short, what we're going to be doing is it's a little bit like how Ethereum 2.0 is going to be working, where we're going to basically have shards. We're going to be doing sharding. And what it means is that you're actually going to be able to take the performance or TPS on each shard, and you can actually add them linearly. So, our plan is to, shard data globally across different swarms that we have. And we're also going to have shards that are they're basically geofenced. So the short answer is that 10,000 is kind of more of a floor than the ultimate max. And yes, we can scale horizontally.
Okay, thank you so much. And I think that would be a really good answer. So the next one, can we please have Taxa to answer this question? I think it's from YouTube.
Sure.
Yeah, so the question is Taxa publicly available as a token now to buy, or is it still in a project mode?
Okay, yeah. So a little bit more introduction about Taxa token. So first, Taxa token will be launched really soon, in early May. And the usage of Taxa token first is to provide a minor incentive to maintaining the network. Everyone can contribute the meaningful computation. It's not the hash power, but executing T-service for the T-services for others, and gaining T-service and gaining the Taxa token as a reward. And also, Taxa token is a cross-chain asset. So, and it's also the value unit inside the T-services. So no matter which blockchain you are supporting for your T-service, the value unit is always the Taxa token. And yeah, so hope that answers your question.
Okay, sure. And also we've got questions for Kevin. And I think Kevin has already answered it through the chat. So if you're interested, please go through the chat. And
but I think for the YouTube live audience, maybe it's good to repeat it just to make sure that people on the YouTube live, because
live. So we have a question for Kevin from Mehmet Rifat. He asked, Kevin, is the business model for Storj targeted purely at spare capacity, or would you envisage business buying and hosting storage capacity? So we've got the answer from Kevin. You might want to store database snapshot for Bluzelle. If there is an S3 compatible snapshot function, we should natively support it. Yes. So I hope that's
let me add to that one as well. I saw another question about is Bluzelle and Storj competitors? I don't think so. I think Kevin already gave example, right? So Bluzelle is a database service; they need storage, and so it could be complementary. But also, of course, each the projects please speak on your own as well. So Neeraj or Kevin, you want to add to that?
Yeah, I can comment on that. We get a lot of questions because I think it's not always clear to people, especially non-developers, so not necessarily a lot of the current audience, but a lot of questions come up of like, well, what's the difference between Bluzelle and say IPFS or Storj or some of the other storage solutions? And it's pretty much what you said, Bruce. I mean, we are a database service. Our goal here really is to provide to application developers, especially a decentralized place to store data, NoSQL data in a key value store. This is a complementary service. It doesn't really compete necessarily with IPFS and Storj. I mean, obviously, you could argue that you could use Bluzelle to store files, and on the flip side, you could use IPFS and Storj as a database. Not necessarily the best use of either service. So yeah, I think we're all complementary in that regard.
Okay, thank you, Neeraj. And also, there's a few questions about price and mining for NKN. I don't think it's the right kind of event for this one, so I will not answer that one, but we are happy to answer offline because, first of all, we don't speculate on price. Secondly, mining is probably not so relevant for the Web 3.0 developers. Okay. I think, Susie, do you have any other questions in the pipeline?
Yes, I do have a few for NKN.
Okay, maybe we'll pick a few that are more representative, and then we'll check the other projects as well.
Okay, sure. So I have one question for NKN. It's from Wilson. He said, could you explain how can NKN scale better than the native network infrastructure? Maybe
Okay, so I would say, yeah, so I can answer this one. So I would say NKN is based on the current network infrastructure. NKN is so it is an overlay network. That means it cannot work if you don't have existing network infrastructure or connectivity. It is like another layer on top of the existing network. So yeah, I wouldn't say they are on the same layer or scales better or worse. It's just like different layer, but NKN is designed in the way that it kind of can scale arbitrarily, or you can cut horizontally. So you can like add a million node or 1,000 node or a billion node doesn't make that difference in NKN. So everything scales pretty nicely in NKN. That's the architecture.
Mm-hmm. Okay.
Okay. So Yilun, there's also a related question in the Q&A. So are there any latency benchmark on NKN? And so that's kind of the
Okay.
probably similar to, yeah, you probably have seen in the Q&A section.
Yeah, I said now. Okay. So I would say for the because the benchmark the latency kind of change a lot, depends on where you send it, where the sender and the receiver are. So it fluctuates a lot, but more the throughput is we find it more like reliable. Or like consistent, because it's kind of not that latency intensive or sensitive. So we do have a benchmark on the throughput, which is based on our like aggregate throughput algorithm. So for like the free relay mode, we can achieve like around over 10 megabits per second. Yeah, just for like at least for my home or a few of our like test servers that we have tried. And also for the paid tuna session, it's much faster. You can reach like over 100 megabits per second pretty easily. Yeah, that's the throughput part. So yeah, the aggregate throughput part actually trade off a little bit latency for like a better throughput. So that's why it might not be optimized for latency, but it is optimized for better like throughput.
Okay. So there's next question actually from the Q&A from Slavash. So for Bluzelle. So I have heard Solana's consensus POH solve the TPS performance. Is that true? And can you use same consensus to increase TPS?
Can't really comment too much about, let me just see the question here. So I've heard Solana's consensus POH solves the TPS performance. Well, we're not, as I mentioned in my conversation, my presentation, one of the points I was trying to make about adoption of Web 3.0 is accepting the fact that a lot of 3.0 technologies are not anytime soon on a performance level going to match up to 2.0, but that's not necessarily reflecting this. Our performance is increasing. I mean, as I said, we can scale horizontally. That's a major advantage we have. Our focus right now is not on TPS. Our focus right now is on reliability and the ability to store as much data as possible and cater to the largest group of developers and making eliminating the friction to use our technology. So I'm not going to really comment on Solana's consensus because I'm not super familiar with it, but indeed we have a roadmap that allows us to scale up our TPS as necessary.
Okay, thank you. So the next question, actually, Susie, do you have any other questions from YouTube Live?
Well, I do have one question that says to NKN that would NKN be fast enough to allow video calls? I think maybe that one is related to N-Mobile, that we could share a little bit more about this.
Yeah, we actually test with the paid session mode, and yes, and our colleagues has been using it with using N-Connect with remote desktop and play the GTA at home. Yeah, that's so it'll be definitely fast enough, at least for like the paid mode.
Okay.
Okay. I actually have a question for Raullen. So I think IoTeX is probably one of the few projects here that have some hardware components in it as well. I think you have some the Pebble and the UCam, and you also have some open ecosystem around that. So can you elaborate about how you encourage kind of the hardware or the kind of non-software kind of developers to participate in this kind of Web 3.0 or kind of blockchain related to kind of applications?
Yeah, thanks, Bruce. That's a great question. Yeah, so starting from this year, we are trying to, talking with different group of developers to have their hardwares actually onboarded into the IoTT network. So the model here is pretty simple. So we provide two things. We provide an embedded SDK that talks with our device style, talks with our blockchain, talks with our storage backend. So that's one. Another one is like the token economics. So we actually discuss with them about how you want to design your token economics to actually maximize utility your machines can provide. So for example, so we're working with a team who's doing machine learning in the past. So they want to encourage like a bunch of machines to get online, to provide data, to facilitate their model. And then the token economics here is pretty interesting. So they want to like actually sell their model to some community or maybe other people who use this one, and use the profits to actually pay out to the machines who generates data. Right, that's sort of like the magic recipe here we use, to work with different developer groups to get the thing going. Yeah, I think by end of this year we should see like 3 or 4 new groups of machine get onto IoTT network.
Okay, thanks, Raullen. Yeah, that's kind of exciting because we always were thinking about making a NKN mine ourselves, or at least have a third-party supporter. So that's kind of good lessons from you guys as well. Thank you.
Cool, thanks.
So I think, Susie, I think probably we have now got to the end of this summit. So I think we have lots of good presentations and from our speakers, and also good questions from the audience. So we'll stop the live streaming today, right now, and all the videos will be available. I think I saw Raullen already share his presentation, and if some other speakers, you want to share your speakers, feel free. And so we'll definitely make the video available and to everybody so you can replay. And thanks again for joining us. And if you joined us, didn't see the beginning part of the live stream, you can find out that Web 3.0 actually is more than just crypto and blockchain. So it's really the future is how we can actually challenge the Web 2.0 company and make the Web 3.0 something that people every day use, and they don't even notice it's powered by blockchain anymore. So with that, thanks again, and I'll see you next time. Thank you. Bye-bye.
Bye.
Thank you.